Today we discuss about another question, important question. Let X T be a matrix space. X T be a matrix space, and then define delta. Define delta. Define delta on X. Okay, as delta xy equal to minimum of dxy 1 dxy 1, then we have to show that then we have to show that a subset u is d open if and only if it is delta open. Okay, so how we prove it? This is an important topics. Now start with simple. We claim that there exists a bounded matrix on X which is equivalent to D. Okay, let X, Y, Z. To prove it, let X, Y, Z belongs to X. Let X, simple X, Y, Z. X, Y, Z belongs to X. Then if dxy less than equal to 1, if dxy less than equal to 1 and dyz less than equal to 1, then delta xy equal to dxy and delta yz equal to dyz. Delta yz equal to dyz. Okay, hence delta xz equal less than equal to dxz, because delta xz equal to minimum of dxz and 1. So we see that delta xz equal to less than equal to dxz and less than equal to dxy plus dyz. Okay, less than equal to this equal to delta xy plus delta yz. Okay, obviously the matrix delta is bounded, that is X is bounded in delta. Obviously delta is bounded, then delta is bounded, then that is X is bounded. In delta, for X subset of this one, for X subset of B delta X are equal to those X dash belongs to X such that delta X dash X less than R. For any X belongs to X, and R greater than 1. let u be d open, let u be d open and x belongs to u. Then there exists r greater than 0 such that r greater than 0 such that bdx comma r subset of u, bdx comma r subset of u. Okay, that means delta is bounded, then x is bounded, and obviously then u is u b d open and x belongs to u, then there exists r b d x are subset of u. Okay, now if this holds for r, if this holds for r, then it holds for any epsilon less than r, then it holds for any epsilon such that 0 less than epsilon less than r. Okay, so we may assume that 0 less than r less than 1. So we may assume that so we may assume that 0 less than r less than 1. If 0 less than r less than 1, in such case b dx are equal to b delta xr. In such case so that b delta x are subset of u, so that b delta x are subset of u. Okay, therefore u is delta open. That means u will be d open. This implies that u is delta open. Okay, now we conversely, if v is delta open, then it is d open. Okay, how we prove it? We write it. Let we erase this portion properly. If v be delta open, okay, then we have to show that this is d open. Then there exists r1 greater than 0 such that b delta y r1 subset of v for any epsilon 1 less than r1. We assume that we assume that this one for any epsilon 1 is R1, we write it here, subset of V, then for any epsilon 1 is then R1. Okay. Then we assume that 0 less than R1 less than 1. Okay, in such case B delta 1, in such case B delta y R1 equal to B dx R1, B dx R1. Okay, since B dx R1 subset of V and B dx R1 subset of V, so V is delta open, V is delta open. Okay, so V is D open. That means a subset U is D open if and only if this one is a subset U is D open if and only if it is delta open. This one is right. If we write here U be delta open, then this one is U, this one is U, and this one obviously U. So we write it if V be delta open, then if and only if this one is D open. Next question, next we further discuss about, so we further discuss about Hilbert cube. Okay, now we erase these questions. Now discuss about Hilbert cube. So Hilbert cube, if x be the set of sequences xk, let x be the set of sequences xk such that 0 less than equal to xk less than equal to 1 by k for all k belongs to n. Okay, then dxy equal to, then define dxy equal to summation k equal to 1 to infinity xk minus yk square whole to the power half. Then so that we have to show that question this one, we have to show that D be a metric on X, D be a metric on X, and XD is called Hilbert cube, is denoted by an XD. This metric space is called Hilbert cube. And usually denoted it by IW or I infinity. Okay, then usually denoted it this. Note that summation x square less than infinity for any x belongs to I infinity. Okay, and we obviously recall this triangle invertibility in Rn for any n. Now we progress with these things. Obviously we think about that since this one be a metric, so we tell about that dxy greater than equal to 0, dxy greater than equal to 0, and dxy equal to 0 implies x equal to y. That means xk equal to yk. Okay, and dxy equal to dyx and dxz less than equal to dxy plus dyz. This one happened by Minkowski inequality. Okay, so now since summation 1 by k square be convergent, summation 1 by k square be convergent in the series k equal to 1 to n summation x k square convergent by comparison test, then the series summation k equal to 1 to n mod of x k square convergent by comparison test, convergent by comparison test. Okay, hence the sequence xk belongs to L2, hence the sequence xk belongs to L2. Okay, so hence the Hilbert cube is a subset of L2, then the induced matrix on Hilbert cube is the matrix also. Okay, then hence the Hilbert cube is a subset of hence the Hilbert cube be a subset of L2. This one is bounded here, then this one is subset of L2, and the induced matrix on Hilbert cube is and the induced matrix on Hilbert cube is also a matrix, hence D be a matrix on X, Okay, in this way we also talk about these things. 1 by k square be convergent, then the series is convergent by comparison test, and hence the sequence belongs to L2, then the Hilbert cube be a subset of L2. The induced matrix on Hilbert cube is also a matrix, hence D be a matrix on X. Okay, so we talk about now Hilbert cube. This space is called Hilbert cube, and this one is usually denoted by I omega or I infinity. Next we talk about another open set on Hilbert cube. This one we totally erase these portions. Next, we develop this one. Any open set in Hilbert Cube I infinity is the union of open subsets of the from these. Next questions. Any open set in Hilbert Cube. Any open set in Hilbert Cube I infinity is the union of open subsets of the from. Is the union of open subsets of the form U1 cross UN Cartesian product xn plus 1 Cartesian product xn plus k Cartesian product where xk equal to 0 1 by k for k belongs to n and where ui are open in xi and where ui are open in xi for 1 less than equal to I less than equal to n and n may be vary okay. Then we talk about next questions. Simple. This one is U be open in I infinity where U be open in I infinity and x belongs to U and x belongs to U. Okay, let epsilon greater than 0 be such that px epsilon subset of U. Choose n belongs to n. Choose n belongs to natural number set such that summation n plus 1 to infinity 1 by k square less than epsilon square by 2. Then the set bx1 epsilon by 2 root n cross bx n epsilon by root 2 n to root 2n and cross x n plus 1 cross dot x n plus k cross dot. Okay, is contained in U. Obviously is contained in U. Okay, because these sets are, that means we considered this one 1 by k square less than epsilon square by 2. Then the set this one is contained in U and x belongs to this one. x belongs to this one and this one are subset of u. Okay, so x belongs to this bx1 epsilon by root 2n cross bxn epsilon by root 2n cross xn plus 1 cross xn plus k cross subset of u. Okay, where u equal to u1 cross Cartesian product ua cross xn plus 1 cross xn plus k cross then we see that u we open, then we see that u we open, and obviously u I infinity is the union of this one, u be open. Okay, then I infinity is the union of the open subsets of the form of the union of the open subsets of the form u1 cross un cross xn plus 1 xn plus k when open subsets you be the open subsets of the form, we erase here, of the from this one. Okay, of the from this one where xk is 0 less than equal to 1 by k, 0 comma 1 by k closed interval. Now we further proceed. Another problem we discuss. We erase this one also, then we discuss next problem. Next problem is so simple. But today we stop here. Today we stop here.